Hello everyone, welcome to part 9 of our tutorial series where we learn the basics of Unity and create a game inside of the Unity game engine using C# while going over in detail the scripts we use. When we left off, we printed the velocity of our object and realized that if I hold down the mouse button or the key to make our character go, so the vertical axis. So right now I was pressing up arrow, but as I could be pressing also W to go forward. And as you see here, the velocity increases as we press the button, even past our desired speed. So let's fix that. Let's give it some boundaries. So let's open up our code here. And let's delete this. We don't need this. And oops, I might have deleted a little too much. Yep, I did. Okay. And let's start doing a little more programming. So this being our target velocity here, we can change now 10 to be our speed, so we can edit the speed inside the inspector. And after that, we can start applying the force. So let's get the current velocity. So these the debug information that was in our Unity console can be stored, and then we can compare it to how fast we're going and how fast we want it to go. So to do that, we're passing already a vector3, so we're gonna, and that's what velocity is, and so we're gonna store it in a vector3. So we're gonna do vector3 velocity, and we're gonna make it equal to, and we can grab our rigid body, which we've already stored here. So we can just do rigid body dot velocity, like so. And now we can see the difference of the two velocities. And we can do that by putting it in also another vector3, since we're subtracting. And one thing we need to learn about the rule of subtraction, addition, and multiplication, you can only multiply or add things that are alike. You can multiply meters with meters to give you meters, right? We can multiply apples times apples to give us more apples. We can't multiply apples and fish to give us apples, right? So to do the difference, we do a vector3, and let's call this velocity change, and let's make it equal to our target velocity minus our current velocity. So, and we've already stored this, and we can do it right here. Let's separate these two a little bit. Okay, so after that's done, we can now clamp. And what do we know about clamping? So let's pull out my favorite tool, Paint, right here. The best tool in the world, by the way. And a clamp, basically, and what we know about clamps, think about in general, you know, let's draw one. That's a clamp. There you go. And there might be a little spring in here, right? And it holds something here, right? So knowing this information about the real world clamp, a clamp in C# or code, basically in math, because that's what code is, it grabs the current value and the minimum and maximum value and clamps it between those two. So if let me undo this. if we have, because right now we have negative infinity, and not really, there are bounds and ins and floats, but for the most part, let's call them negative and positive infinity. However, those aren't the correct definitions, but we can overlook that. So let's say we have a number, bazillion, right, somewhere here, right? And then we have, negative 50. And we want to be modest, and we say, well, all we care about is the information here. So we care all about the information from 0 to 10. So no matter the input, basically it will say here, if we go any further, we just stop it here. And if we go any further this way, we'll just stop it here. And it clamps it like that. So they clamp on both sides, and so they can't go past those two edges. So they're kind of like clamps on a number line, preventing it from going in directions. So let's go back into our code. Let's do that here. And to do that, we can simply go and clamp the information that we want. And so the information we want is the X and a Z. And why is that? Well, and you might be wondering, why do we want the X-axis if we're only going in the Z direction? And that's because if our cube turns and let's say X becomes forward and we're applying force this way, then we can simply add the velocity there and not worry about it. So basically we're adding velocity to both sides, so that if we turn and this is forward, we go this way. If this is Z, we go this way. All that fun stuff. And we don't really care about Y right now. However, we will make the character jump later on. And so to do that, let's clamp those two together. So velocity change. So let's make sure that the change dot X, so we're only grabbing the X, equals. And since we're doing a fancy math function, let's call math, right? It's math F works, and dot, and let's see what happens. And we scroll down, and surely enough, there it is. It says, and it even has lovely information for us. It says, float math clamp, float value, minimum, maximum, and clamps a value between a minimum and a maximum number. So there you go. That's the definition. And so what are we clamping? We're clamping this information, velocity change dot X, and then our minimum. So it'd be our negative key, so back. So as we said, horizontal has positive and negative. So the negative would be negative maximum velocity. So maximum velocity, which is 10 for right now, but we can change the value if we want. And the positive is maximum velocity. And that assures us that our value doesn't go past 10 and negative 10. And we can copy this. Control C, Control V, and here we just change it to Z, like so. Enter. And now we can make sure that we don't fly off the face of the earth if our increase in velocity gets changed. And that brings me to a story. When I first started doing programming, I wanted to make my character go really fast, and I had a lot of functions and just this really, interesting and elaborate project, and I was not zeroing out the velocity change. I was just putting more force down. So what do we know here? So let me just quickly explain this story. So my character was getting pushed here 100, right? So my cube, and I was pushing another 100 newtons, I guess, down on the character if we raise off the ground. And what ended up happening was that we'd go super fast, and as soon as we got off the ground, I would slow down because the mass of the object got greater, and I didn't ignore mass, and it was just terrible. So anytime you're setting vectors and values and you're doing a vector 3, zero out the values you're not using. So let's copy this here, and we can just do y equals 0. Okay, and there we go. So now we have these clamps, and we can add a little bit of force, right? So what do? We add force to our rigid body, the physics engine, our rigid body dot, and we're really adding the force. So we're adding the velocity, add force, and here we can do velocity change. And to make it make sure it doesn't get affected by the mass, so we can make the object weigh 100 tons and it won't matter, we do that by putting a comma, and we have this thing called force mode. Force mode is an enumeration. So to do that, we do force mode. So we're going to call a force mode, right? Force mode. And what kind of force mode? So dot. And now here we have all these fantastic force modes. But what we want is a velocity change. Add an instant velocity, a velocity change to a rigid body ignoring its mass. And that's what we want. And then we hit a semicolon to say that we are done with the code. And we hit save. After that, we can print this information to make sure that we did it correctly. Print, and we can do this lovely thing. I'm just going to copy and paste, since I'm lazy, like so. Hit save, Control S, go into Unity, and hit play. So we can turn around. Beautiful. And when we go forward, we see that it is clamped. It goes to 10 at times right here, and we're turned a little bit so the force is getting distributed evenly, and magic happens here. And there is a little bit of sliding since it is a physics engine, and it looks great. So with that said, let's go to part 9 and add a little jumping feature, and see you there.